Welcome, everyone. My name is Thomas Pauly, and I'm here today with Justin Welsh, Ronald Cabello, and Christopher Tang, and we are the 4 members of Chemical Engineering Team 6. Our project is titled Water Consumption Analysis and Reduction for Pfizer Groton. We look forward to speaking with you today about our assessment of water consumption at the Pfizer Groton site. With that being said, let's begin the presentation.
First, we'll discuss background information about the Pfizer Groton plant. It's a 160-acre site with 2.8 million square feet of laboratory space. All of Pfizer's water comes from the city of Groton. Utilities including the chiller plants, the boiler, cooling towers, the fuel cell plant, and the power plant over the campus account for the bulk of water usage on site. The big thing to note is that although water consumption has decreased, the cost has increased recently. The overarching objective of this design project was split into 3 categories: the problem, the scope, and the goal. The problem here is that Pfizer consumes a large volume of water and utility costs are high. The scope is to analyze and assess the water consumption, and the goal is to identify opportunities for water consumption and cost savings.
Taking a look at the water consumption at the Groton plant, as stated before, the amount of water consumed has steadily decreased over the past few years as seen on the left side graph. A cause for this decrease could be from the scaling down in manufacturing at the facility since 2008. 2020 is the only exception to the trend due to increased evaporation from higher ambient temperatures in the summer, resulting in more water being consumed that year. For the cost of water in dollars per meter cubed, however, it has been increasing since 2016 due to rising costs at Groton utilities. It's because of this decrease in water consumption and increase in water rates that from 2017 to 2019, the yearly cost of water has remained about the same at $1 million as seen in the right side graph. The graph here on the left shows the total discharge of wastewater from 2018 onward. The blue bar represents the wastewater discharge into the Thames River, and the orange bar represents the city sewer discharge. As you can see here, the amount of water discharged to the sewer is much higher than that going to the river. The graph on the right represents only the annual sewer discharge cost since it's free to discharge into the Thames River. Here, there has been a substantial increase in the total cost of sewer discharge per year, resulting from the rise in discharge. Note, for the 2018 discharge cost, the first 6 months of that year was not recorded because the city of Groton didn't start charging Pfizer back then.
Our technical solution is the creation of a wastewater treatment plant. Through the use of a treatment plant, we can divert the wastewater being sent to the sewer and treated directly on site. 652,000 meters cubed of wastewater is being sent into the sewer at a rate of $1.90 per meter cubed. This expenditure would be eliminated through the construction of the wastewater treatment plant.
With this solution, a notable change to the site would be the installation of a new piping system that would allow Pfizer's wastewater to be diverted to the new plant and later discharged to the Thames River. For construction materials, the team will save on upfront costs through suggesting more affordable yet durable materials, such as polyvinyl chloride piping, fiberglass reinforced plastic, and various concrete structures. The proposed site for construction of the plant is the open flat land adjacent to the West Basin on Pfizer's campus. This location is in close proximity to the power plant, which is the largest water consumer on site, so it is ideal for optimizing water reuse. Pfizer's wastewater will be treated all the way through the tertiary stage, and the key secondary treatment process for the plant will be the activated sludge process.
A wastewater treatment plant consists of 4 levels of treatment, which are the preliminary, primary, secondary, and tertiary treatment. During the preliminary stage, most of the large objects in the wastewater get removed through filter grids. Next, during the primary treatment, up to 50% of the suspended solids get removed. Afterwards, the stream will then go to a secondary treatment phase where up to 90% of the pollutants are eliminated due to the microorganisms decomposing the organic material inside the stream. Next, during the tertiary treatment, harmful nutrients will be removed from the stream and then disinfected with chlorine.
To see if the creation of an on-site wastewater treatment plant would be economically advantageous for Pfizer, our team utilized the 2019 wastewater discharge data to find that the daily sewer discharge for the site was roughly 1,800 meters cubed per day. This value was compared to online sources, which provided the estimated capital cost for a 568 meter cube per day plant of roughly the same size. Due to similar sized plants, we assumed linear growth and applied this to Pfizer using a direct proportion. Using this comparison, we found that there would be a maximum upfront capital cost of roughly $4.7 million for the creation of the treatment plant. A similar comparison was used with the estimated production costs, which referenced a 2,877 meter cubed per day treatment plant of about the same size. Based on this, we found the maximum production cost for the facility to be about $375,000 per year.
Although the technical plan has been established, it is important to remember all supplementary considerations. These could be both positive or negative. Our group observed that there are both ethical and environmental considerations that weigh in on this topic. These span from the perks of water reuse to the potential increase of carbon emissions. Furthermore, when implementing a wastewater treatment plant, process safety needs to be meticulously crafted and planned for ideal working conditions.
In summary, our solution will save $1.25 million per year, comply with environmental regulations, be ethically conscious, and will have the potential for water consumption cuts.
That concludes our presentation. We'd like to thank everybody who came and watched, and we sincerely hope you learned something.